everyone. And today we arrange our webinar on the topic of the value addition of food product by drying and application of ultrasound technology. So before the moving to the talk, okay, let me introduce our speaker, Mr. Abhishek Chandra sir. Okay, and he is a PhD scholar and a Department of Food Engineering, National Institute of Food Technology, Entrepreneurship and Management, and Ministry of our Food Processing Industries, Sonipat, Haryana. And he has a vast experience in the field of our food engineering and technology. And he attended the many number of the our conference and published the lot of the article, and he is working as the our reviewer in the our journal like the Journal of the Science and Food and our Agriculture and Journal of the Science and our technology, our Springer. And he has also taken the many number of talk and a webinar and to motivate and encourage the our young mind. So let's hear from him. And now I hand over this session to Abhishek sir.
Thank you, Sandeep sir, for your kind introduction. And I am really thankful to Sandeep sir and the team Parul University for giving me this opportunity to talk on this webinar on the topic of value addition of food products by drying, application of ultrasound technology. So basically, for more than 5 years, I'm associated with this field of drying and various aspects of novel processing in collaboration with drying for the processing of fruits and vegetables. So the fields include vacuum impregnation, ultrasound technology, then association of osmotic dehydration with ultrasound technology, and various aspects of these topics and various research works related to the drying of fruits, vegetables, fabrication of dryers, then various emerging technologies, etc. So today I would like to talk on the topic of application of ultrasound technology. We will focus on the ultrasound technology, how it is helping the drying process in order to make the fruits and vegetables uh, to be preserved for a higher shelf life and to enhance the product quality in the industrial aspects in order to get a better quality product. So the agenda would include, I will go straight from the conventional food processing technologies which the industry is employing and we are researching. Then we'll go to the ultrasound technology. We will understand various concepts of ultrasound technology like the mechanism, the way of application of ultrasound technology in the industries and the lab scale, then the various advantages associated with this technology when we combine this ultrasound technology with drying process for the preservation of fruits and vegetables in order to get ready to eat dried fruits and vegetables. Then the mechanism of ultrasound, like how the ultrasound is being generated and with which mechanism and processes the ultrasound is being used in the industrial machineries. Then all the research data which proves that ultrasound technology is a better in conjugation with the drying process in respect to the conventional drying technologies. It arises as a better technology to enhance the process. And finally we'll come to the limitations of this technology, like what are the areas in which this technology is still lagging back and we need more research to enhance this process in order to get it as a perfect technology for preservation of fruits and vegetables. So in this talk we will go through all these topics. So, firstly, the need for the proper post-harvest handling. We know that after harvesting, the fruits and vegetables are highly perishable. That means it has a very low shelf life. Because of that, we can't store it for a longer period of time. Throughout the course of time, it will start degrading due to the high moisture content of the food product and due to the microbial spoilage, due to humid effect of environmental factors like humidity, then temperature. So we have to keep in mind all of these factors in order to protect our food, because we need to reduce the post-harvest losses of the fruits and vegetables. So we know that a considerable amounts of losses of fruits and vegetables are due to improper post-harvest operation, which starts after the harvesting in order to preserve the fruit and vegetable. So there is a considerable gap between the gross production, that means the amount we are producing from the field, and the net availability to the consumers. So this gap is due to the need of proper post harvest handling. A small fraction of fruits and vegetables are utilized for processing. That means the amount we are producing is a huge amount, but for processing we are available to process it for less than 1%. And a small amount is also exported, like 0.5% for fruits and 1.7% for the vegetables. So we can see that after harvesting we can only utilize a very small portion for the processing and export. So we need to focus on the post-harvest handling processes in order to enhance this usage or processing and export. So the post-harvest losses is around 20 to 40% in general, if I talk, which considerably results in losing of market value and consumer acceptability. That means if the product is being degraded or it has spots, marks, or microbial spoilage, then the consumer acceptability will also reduce and the market value is also reduced for the food products. So the reason behind this is improper handling and storage. Like we can categorize it into two: mechanical losses, which include bruising of the peel of the fruits and vegetables, then somewhat cracking, then cuts, microbial spoilage by fungi and bacteria, because these are the main processes during transportation. During transportation, mechanical losses are very much higher, and due to bruising, cracking, cuts, microbial spoilage, the losses are becoming higher and higher throughout the course of time. And there are other kind of losses like physiological losses, which arises due to change of respiration. That means the interaction of the fruits and vegetables with the outer environment. After harvesting, the temperature of fruits and vegetables is already higher, so it needs a proper pre-cooling. Then we need subject it to the processing technologies. So changes in respiration, that means interaction with the outer atmospheric gases, transpiration, like transfer of moisture with the environment, then the changes in pigments which are responsible for the color of the fruits and vegetables. So the impact is also on the pigments like carotenoids and betalain and other pigments. Then the organic acids present in the fruits and vegetables, plus the flavor. So the improper handling, we are focusing on the mechanical losses and physiological losses. Then after harvesting, we go for the conventional. If we go for the conventional food processing techniques, so it has some limitation. That means if we talk about the most general processing technique for preservation and enhancement of the shelf life of the fruits and vegetables, then we can see and we know that sun drying is the most traditional and simple method to dry the food products. And it depends entirely on the natural environmental condition. That means availability of the sun and availability of the temperature, proper temperature, and throughout the day how the sun is showing, and the humidity of the atmospheric condition, all depends on the sun drying. Then the drying process is also very slow. It takes a huge amount of time, and throughout the course of time the spoilage is also takes place in some conditions, which is dependent on the type of the fruit and vegetable. So the labor requirement is also very high in this process, and also the exposure to the surrounding environment, the drying process is being affected. So if we see the other conventional food processing techniques like hot air drying, the energy consumption is very high because of the drying period. The drying period is comparatively very long. So due to high temperature drying, the energy consumption is very high. That means we are drying the food products at a temperature of 60 degrees Celsius or 70 degrees Celsius. So the energy consumption will be very high, and it takes also a lot of time, like 8 hours, 9 hours to dry the whole product to the up to 6 to 7 moisture content on dry basis. So the quality deterioration of the final product is also happening during the hot air drying process. That means the loss of pigment, color changes is very high. Then the shrinkage in the food products is very high. That means we are losing the proper texture of the fruits and vegetables during the conventional drying processes. So in some cases, uneven drying is also occurring due to lack of proper distribution of the uh, temperature, or we can say that the proper distribution of the fruits and vegetables, whether in the slice form or cubes form, for the preservation. Uh, in microwave drying, if we go for microwave drying, there is overheating or uneven drying. And in freeze drying and hybrid drying, we are combining two or three kind of drying processes. So that uh, high cost is included in this type of processes. In freeze drying, it takes a lot of time. Obviously, it preserves the food quality, but the drying expenditure is very high. It is energy expensive process. So there are different limitations during this type of conventional drying processes. So the question arises on the benefits, energy efficiency, and the environmental impact of these type of conventional food processing technologies in order to preserve the fruit and vegetable quality. So the need is to maintain the quality of the product with the cost effectiveness for the drying technologies. We need to also maintain the quality for consumer acceptability, and we need to also reduce the cost for the processing. Here we're talking about the drying technologies to preserve the fruit and vegetables. So we know that we need a food product, the final product, which is of very high nutritional value. We talk about the nutritional retention, like we need to retain the antioxidants of the fruits and vegetables. We need to retain the phenolic content. Then we also need to require the various pigments present in the fruits and vegetables in the final product. So it look so that it is consumer acceptable, and it looks appealing in terms of sensory. So it should have a good sensory properties. That means the taste should be intact, and aroma, flavor, everything should be intact after the whole drying process. We need to retain the sensory properties as much as possible throughout the whole process. But we need to require a very less drying time. That means if the drying time is higher, we will reduce the sensory properties and nutritional value of the fruits and vegetables. So we need to reduce the drying time. In general, we talk about the processing time. Then we need a higher shelf life of the product. That means if we're drying the fruits and vegetables as ready to eat products, RTE products, so we need an enhanced shelf life so that the product can be available to the consumers for a higher period, minimum for 6 months or more than that. It would be best to get the higher shelf life with less additives, because the preservatives we are preferring to add it less in order to get a better quality product. So there are many emerging processing technologies available in the market, in the industry, which are going on under research. So how we combine the drying technologies with these emerging technologies in order to get a better product with higher nutritional value, good sensory properties, less processing time, enhanced shelf life with less additives. So the concept is when we take fresh fruits and vegetables and we go for the drying process in a dryer to get a dried fruits and vegetables. So we can employ the pre-treatment methods before the drying process in order to enhance the moisture diffusivity, or to reduce the drying process time to get a better quality product. So the pre-treatment can be employed before the drying process in order to reduce the drying time. And in second way, we are applying the pre-treatment method or the novel technologies with the drying process only. Like when the product is drying, we're applying the technology like ultrasound technology. We are applying it with the drying process, which we can say in a scientific term the airborne ultrasound. That means when the product is drying, we are also drying the product under the influence of ultrasound. so as to increase the moisture diffusivity and to get a better product with better water activity, low water activity. So these are the two methods. We are applying pre-treatment before the drying and applying the treatment with the drying process. So we need to know the ultrasound technology. So what we know so far that the sound waves which are exceeding the audible frequency range, that is which is greater than 20 kilohertz, is termed as ultrasound. So when the acoustic waves propagate through a medium may be water or it could be air. So when these kind of acoustic waves, ultrasound waves propagate through the medium, they generate continuous compression and rarefaction. That means uh, one in a fraction of second, the compression occurs and then expansion occurs. Then there is a cycle of continuous compression and rarefaction in the medium of the particles, and it also affects the media and the product we are keeping in the media, in air or in water. So I will talk about this later, that how we are giving this kind of ultrasound processes to the fruits and vegetables. So a high amount of energy is being produced due to the turbulence, and which increases in the mass transfer. Mass transfer means we are taking out the moisture and reducing the moisture of the fruits and vegetables throughout the process of ultrasound. So based on the intensity and frequency, ultrasound waves used in food application can be categorized in two categories. Either it is low intensity ultrasound or it is high intensity ultrasound. So as we can see in this figure, that ultrasound starts from 20 kilohertz and it could may increase up to 100 megahertz. But the application for the application in the food industry or for the processing of food, we need low frequency power ultrasound, which is in the range of 20 kilohertz to 100 kilohertz. But for preserving the food quality, we may go up to 40 kilohertz only. So we have to keep the frequency lesser for the better quality and optimized ultrasound treatment. Then why the use of ultrasound technology is helping us to get a better product. So the phenomena of ultrasound technology involves the acoustic cavitation. That means the bubble formation occurs when the ultrasound is applied. The bubble formation occurs, and we can see in this figure how these bubbles are continuously forming inside the media, and it is bursting. So in the product also, whether it is a fruit slice or vegetable cube or vegetable slice, this kind of phenomena is continuously occurring, which is helping in reducing the moisture content partially. And there is also the forces of sponge effect, which is affecting the fruits and vegetables. That means there is a continuous contraction and rarefaction inside the media, which is helping the fruit to get reduced in the moisture content. So these are the two phenomena which are working together to make the ultrasound technology useful for the processing of fruits and vegetables. So there are three methods by which we can employ the ultrasound technology with the drying of food products, whether it is for fruits or vegetables. So first we will talk about it one by one. First, it is airborne ultrasound. That means the media is air, and we are applying it with the drying process itself. That means at the time of drying, we are simultaneously keeping the product in contact of the ultrasound through the air medium. Second is ultrasound pre-treatment, which is we are doing before the drying of the food product. That means in this case, we are not providing the ultrasound simultaneously with the drying process, but we are providing the ultrasound before the drying process of the fruits and vegetables. And during the ultrasound pre-treatment, the moisture of the fruits and vegetables is partially reduced, and it expands the pores of the fruits and vegetables, which helps in better drying of the fruits and vegetables with lower drying time. And third process is contact ultrasound. That means there is no medium. The fruit and vegetable product is in contact with the ultrasound plate, and simultaneously the drying is occurring. So this is the most effective in all of this, but in this process there are industrial limitations. So we will talk about all these three techniques, like how we are using this technique, what are the main benefits of this technique and its limitation, and how we are using it to get a better quality fruit and vegetable product. So the ultrasound technology helps in getting a better nutrient retention in the final product. Then the drying rate is very high. That means the product is drying very fast due to the influence of ultrasound. Then because the drying time is very low, so the energy consumption is simultaneously very low. So it is a better, because it is our priority to reduce the energy consumption throughout the process. And the color retention is very much high. As the drying time is low, the processing time is low, the color retention is very high in the final product. Then there is an increase in the convective mass transfer. That means the transfer of moisture from the food product is increasing due to the influence of ultrasound technology. In a way, we are increasing the effectiveness of drying by the application of ultrasound. Then the removal of moisture which is strongly attached, that means the bound moisture, we can also remove the bound moisture effectively by the use of ultrasound, because uh, under the influence of ultrasound the pores become larger, and due to continuous expansion of the food product, the moisture is being efficiently removed from the food product. Then the moisture diffusivity, as I told, it is increasing the effective moisture diffusivity, and the final product we are getting is of very low water activity. Here, see, the low water activity is required because uh, any food product is susceptible to microbial spoilage. But the water activity, if the water activity is very low, so we can protect the food for a longer duration, uh, to prevent the microbial spoilage, and hence it increases the shelf life of the fruit and vegetable. So there is a question in mind, like how the ultrasound is being generated for the application in the food processing technologies. So the ultras, for the generation of ultrasound, two type of transducers is being used. First, the piezoelectric transducer. As in the figure, we can see that there are piezoelectric elements separated by an electrode. So when an electrical force is applied, the piezoelectric elements vibrate due to the product, and hence it produces piezoelectricity. And due to this vibrational force, the ultrasound is being generated in through the piezoelectric transducer. So generally, that this is the tank bottom, and below this piezoelectric transducer is present for the generation of ultrasound. Then another type of transducer is magnetostrictive transducer. Here the ultrasound is being generated due to the effect of magnetic field. When the magnetic field is being provided, these magnetostrictive laminations start vibrating. This, we can see that the layered laminations, this starts vibrate, and due to this vibration ultrasound is being produced. And for the different frequency, the structure of this transducer is different. So for the generation of ultrasound, these two type of transducers is being used. So the method of application of ultrasound. So how we are applying ultrasound to the food products during the processing. So there are basically, if we talk, there are two type of ultrasound equipment. First is sonotrode. That means the ultrasound is being provided through this sonicator probe. So the medium is present uh, in this capacity, and the product is being treated under the effect of the sonicator. So this is more of a kind of localized treatment. That means this is less uniform. That means the distribution of this sonication is not very much uniform. But in this ultrasound bath, the in this medium the ultrasound is being distributed very uniformly. So basically The ultrasound bath is very much useful for providing the ultrasound to the fruit and vegetable medium. So in industrial scale, it would be a larger equipment. So if we see the graphic diagram, we can see that how this is the tank bottom, and below this tank bottom, the transducer is present. And in this tank, the liquid or the medium is present, whether the liquid is distilled water, it could be hypertonic solution, that means sugar solution, in order to provide ultrasound assisted osmotic dehydration. Because if we keep the medium as the sugar solution, the TSS can vary. Maybe it could be 50 TSS, maybe it could be 60 TSS, or maybe it could be lower. So we can also have the phenomena of ultrasound assisted osmotic dehydration, which would enhance the osmotic dehydration in order to reduce the moisture content of the fruits and vegetables. The fruits and vegetables, whether in the slice form or cubic form, are placed in this medium inside the tank in order to get it treated under the influence of ultrasound. So we can better understand in this, like this is an ultrasound probe, as in case of sonotrode, like ultrasound probe sonicator. The food medium is kept in this type of tank inside it, and this way the ultrasound is being given to the food products, and hence the mass transfer takes place. In ultrasound bath, uh, we can go for the two methods. That means the direct application of the ultrasound to the food materials in the tank, or we can use a cage or a medium in order to give an indirect application of ultrasound to the fruit and vegetable medium. So in case of ultrasound bath, there are two methods by which we can provide the ultrasound to the fruits and vegetables. Bigger the surface area, there is a lesser need of the ultrasound pre-treatment time. So if the fruits and vegetables are in the slices form, so the ultrasound application time will be lesser. But if it is in the cubic form, then the time will be higher, because this is due to the effect of the surface area. Higher the surface area, the application time will be reduced. Then how we are associating the ultrasound technology with the food drying. So basically there are three different ways by which we are associating the ultrasound technology with the food drying. First of all, I told you about the ultrasound pre-treatment. In this, the pre-treatment is given to the fruit and vegetable product. After that, we are going for the drying, whether it is hot air drying or vacuum drying or freeze drying. And secondly, the airborne ultrasound assisted drying. That means we are providing the ultrasound with the simultaneous drying of the fruits and vegetables. In this case, both the ultrasound and drying are simultaneously taking place. Then third is contacting ultrasound assisted drying. In this type of drying, the fruits and vegetables are in direct contact with the ultrasound plate during the drying process. In airborne ultrasound, the medium is air, but in contacting ultrasound, the fruit and vegetable product is in direct contact. So in this third type of drying method, so the moisture diffusivity is higher, and the drying time is also the least between all these three. So I will talk about the ultrasound pre-treatment process before the drying. Firstly, so the ultrasound is usually applied either by ultrasound bath or by a probe to transmit the ultrasound waves into the aqueous media. The aqueous media can be distilled water in order to provide the ultrasound treatment inside the tank, or it could be a sugar solution. We can vary the TSS according to the fruit media. That means the if the moisture content of the fruit is very high, that means if it is 90% for the papaya, say, then we should increase the TSS of the sugar solution. But if the moisture content is lesser than 60%, so we can reduce the TSS of the sugar solution for the ultrasound assisted osmotic dehydration process. The acoustic waves induce compression and expansion of the samples. That means the sponge effect and acoustic cavitation. In both the things, the compression and expansion of the samples occur under the influence of ultrasound, and it creates microscopic channels in the samples. That means the pores have become larger in the sample texture, which would increase the better release of moisture during the drying process. So it is basically a treatment in order to enhance the drying process. So in this experimental setup, we can see that this is an ultrasound transducer. This is the transducer, and this is the probe, which is dipped in the tank. Tank is containing a medium, whether it is distilled water or a sugar solution. So the food samples are kept in this tank, and due to the effect of ultrasound, this is being treated. This is the ultrasound generator, and we can note the temperature of the medium and other things through a computer or sensor. So this is the setup of the ultrasound probe sonicator system. And secondly, this one is the bar type. That means the medium, inside the medium, the food sample has been kept whether in direct contact or indirect contact, and the transducer are present below the plate of the tank. So the ultrasound is being provided to the whole reaction mixture, and the treatment is being occurred. Secondly, the ultrasound assisted drying. That means in which we are providing both the ultrasound and the drying simultaneously. So whether it is a hot air drying or vacuum drying, we can provide the ultrasound simultaneously. When convective drying, the acoustic energy induces an oscillating velocity effect. That means the continuous contraction and rarefaction effect occurs, and this will also speed up the drying process. Due to this oscillating velocity effect, the structure of the food material is being exposed to the drying process, and there is an enhanced release of moisture during the drying process, which reduces the drying time and to get a better quality drying product. The diffusion boundary layer is reduced and the water diffusion is enhanced. Therefore, the utilization of airborne ultrasound technology can effectively accelerate the drying process. So, we can see in this setup that this is the airflow is occurring by this. This could be a hot air of maybe say for 60 degrees Celsius, and this is a vibrating cylinder which is producing ultrasound. So in this setup, the under the effect of airflow and ultrasound, the fruit and vegetable sample is kept here, and under the effect of the hot air and ultrasound simultaneously, the drying is taking place. We can see in this B figure that how this is occurring, whether the product can be kept in the cube form or it could be kept in the slices form as desired. Then third type is the contacting ultrasound assisted drying. As I told you before, contacting ultrasound, that means the product would be in direct contact with the ultrasound plate under the effect of drying process. Drying process could be hot air drying or vacuum drying. The ultrasound energy by this process can directly be given to the food materials. And the problem of energy loss, that means in airborne ultrasound, the energy loss, ultrasound energy loss is occurring because the medium is air. But in this thing, this type of contact ultrasound drying, the problem of energy loss is being solved theoretically as the food is in direct contact with the ultrasound plate. Then, when the vibrating system is being directly attached to the food material, a good acoustic impedance matching allows the ultrasound energy to deeply penetrate into the product. That means the ultrasound energy is being directly influencing the food product, whether in the slice form or cube form, and due to this, there is a better transport of the ultrasound energy through the media of fruit or vegetable. And there is a huge improvement in the drying rate by contacting ultrasound, which is better than that by the airborne ultrasound. If you compare with the airborne ultrasound, where the medium is air between the fruit and vegetable and the ultrasound probe, this is a better technique. The direct contact between the emitter and the product makes it difficult to implement this system on industrial scale. See, in industrial scale, we need a bigger type of setup where the output of the production is very high. So it is quite difficult, and it is still under research that how we can provide the direct contact ultrasound uh, for the drying process on the industrial scale. So the direct contact is being difficult in the industrial scale when you scale up this type of lab scale contacting ultrasound drying setup. See, what I was talking about, the ultrasound plate is in direct contact with the food sample. So the food sample is in direct contact. So the ultrasound energy is being transferred easily and without any energy loss to the food sample. And continuously the drying is also occurring in the drying chamber. See, the fan is here, 4 number, and this is the, in 5 number, this vibrating plate, the food sample is being kept, and this is the ultrasound uh, transducer by which the ultrasound is being provided to the plate and simultaneously to the fruit and vegetable sample. Then, if we combine ultrasound with different methods of drying, either it is hot air drying, either it is freeze drying, then microwave drying, and infrared drying, we can combine ultrasound with different types of drying in order to enhance the drying process. So, in hot air drying, the ultrasound effect does increases the water effective diffusivity, and the drying time is greatly reduced because of the production of a microchannel inside the food structure, and it modifies the structure of the materials exposes to it. That means in this process we get a very low water activity final product, which enhances the shelf life. In freeze drying, the freeze drying rate is significantly improved. That means if the freeze drying process takes 24 hours, it would be the drying time would be very much reduced, and hence the energy consumption during the freeze drying will also reduce. In microwave drying, the drying time is decreased, so the rehydration capability and the texture is also improved. See, in this type, when we include the ultrasound technology, we can see the pores are getting larger of the food structure. So the shrinkage is also very much lesser in the final product. If we talk about the shrinkage, that means the reduction of the surface area of the dried food product during the drying process. So the shrinkage is very less, and hence the rehydration capability, when we need to add the dried sample to the water in order to get the original fresh product, so the rehydration capability is also increased, and hence the final texture is also being improved. In case of infrared drying, the hardness of sample is increased. That means we are getting a very much crispier product, final product. We talk about fruit chips like apple chips and other potato chips. So if we use infrared drying with the combination of ultrasound, the hardness of sample is being increased. The drying rate is significantly shortened with the increase of ultrasound amplitude, because this all is because of the formation of microscopic channels, which enables the release of moisture from the sample during the drying process. Then, if we talk about the research which is backing the application of the ultrasound technology in combination of the drying process, we can see that in ultrasound assisted hot air drying process, the findings are the higher the power level, ultrasound power we are talking about, the shorter is the drying time in case of apples. And if we go for the apples of different varieties, we can see that the ultrasound effect has a more effect at low velocity of the air and power. So the effective moisture diffusivity is 54% higher than the drying process, which is using conventional hot air drying. So this type of combinational drying process, when we are using ultrasound with the conventional hot air drying process, the effective moisture diffusivity is 54% higher, which is a huge margin if we talk about the whole drying process, and hence the energy consumption would also be reduced during this process. If we go for the drying of oranges by the ultrasound assisted hot air drying, we can see the findings that the drying time is being reduced by 30 to 45% when we compare it with the conventional hot air drying. So the reduction in the energy consumption are about 12 to 20% is being found when we combine with the hot air drying process. In red bell pepper, if we use ultrasound assisted hot air drying, the drying time savings of 18 to 23% is observed as compared to the conventional hot air drying. If we go for the drying of seaweeds, there is a retention, higher retention of the color properties with in the case of seaweeds, which is a preference when we are going for the drying of seaweeds. Then in case of sweet potato, the effect of ultrasound on the sample reduces as the moisture content decreases. So there is a higher preservation of the color, higher rehydration ratio as compared to the conventional hot air drying. So see, we are getting a better quality product when we talk about the final dried fruits or vegetables when we use ultrasound technology with the drying process. So, what are the various effects of combined ultrasound and conventional hot air drying on the drying kinetics? If we talk about the drying kinetics, we know that the effective moisture diffusivity is increased when we use ultrasound with the conventional drying with the increased temperature. And as we compare with the conventional drying, the effective moisture diffusivity is very much higher. The higher reduction in the drying time, as we compare with the conventional drying, there is a huge reduction in the drying time when we employ the ultrasound. And the temperature we have to keep it low because with the effect of ultrasound we can afford the low temperature during the drying, and due to the extra energy provided by the ultrasound in this combinational drying process, so less intense at higher temperature than lower ones. So in addition with the reduction in the drying time, which is up to 80.3%, also depends on the ultrasound power applied. So higher ultrasound power level results in the shorter drying time. Then the improvement in the drying rate and time of fruits and vegetables using combinational ultrasound and conventional hot air drying also depends on the drying air velocity. That means the air velocity also plays an important aspect in this, whether it is 2.5 meter per second, whether it is 3 meter per second. So the air velocity is also a huge impact in this case. And the type of material to be dried, that means the fruit or vegetable media, the texture of the fresh fruits and vegetable media, or whether it is in the cubic form, whether it is in the slices form, it also impacts the drying process. So this is evident in the case of combined ultrasound and hot air drying of lemon, as it is being reported in the findings. For vegetables also, there is a similar effect as in case of the fruits. It has been observed that increased drying rate when compared to the conventional drying. Then a 30% reduction in the total drying time was observed. Then ultrasound also increased the effective moisture diffusivity by 40%, which helps in reducing the energy consumption during the whole drying process. Then the results of the study showed a decrease in the effect of ultrasonication at higher load density due to the reduction of the transfer area. See, if the load density, that means that we are using a huge amount of fruit slices or vegetable slices at a time, the effect of ultrasound effect is reducing. That means we have to optimize the load density with the ultrasound frequency in order to get a efficient treatment. So, as per findings, it had been shown that the effect of drying temperature on the drying kinetics of tomatoes during the combined ultrasound and hot air drying showed the result is a reduced drying time up to 43% and 65% when the drying had been done at 60 degrees Celsius and 45 degrees Celsius respectively, as we compared with the conventional drying process. Then if we talk about the energy consumption, We can see in this graph that the electrical energy consumed in hot air drying process is very much high as we compare with the ultrasound assisted drying of 100-watt power and ultrasound assisted drying with hot air drying for 200 watt. We can see how the energy consumption is being reducing. So it is a huge impact of the ultrasound technology that the energy consumption is being reduced under the effect of ultrasound. As per findings, we can see that the consumption of about 12 to 20% was observed during the drying of orange. As we compare with the hot air drying, there is reduction of 12 to 20% of the energy consumption in various different type of fruits. Like in case of apple, the reduction of energy consumption is 40 to 54%, which is by a huge margin when we compare with the conventional drying. Then the effect of combined ultrasound and conventional hot air drying on the product quality. See, product quality is a very important aspect when we talk about the consumer acceptability of the product. So we need to get a higher nutritional retention in the final product to obtain a high quality dried fruit and vegetables. We need both better functional properties and both nutritional properties. So the most common quality parameters that are associated with the dried fruit and vegetables include color, shape of the product, then texture of the product like the mouthfeel and the flavor, then the microbial load, because microbial load is also an important aspect because it directly influences the shelf life of the product. Then retention of the nutrients, if we talk about the phenolic content, if we talk about the flavonoids, then the antioxidant content of the fruit. So retention of nutrient is also very much important, and the rehydration properties when we want to rehydrate the dried product. So these all kind of properties influence the overall quality of the dried fruits and vegetables. And the effect of ultrasound is increasing the product quality, the final product quality. As per findings, we can see that there is an increase in the availability of thiamine, riboflavin, niacin, pantothenic acid, and pyridoxine, and improved vitamin in content and carotenoid content. So we can see that the overall nutritional quality of the food product is increasing when we combine in ultrasound with the hot air drying process. That means the conventional hot air drying process. If we talk about the drying of apple, so the color preservation and rehydration rate is also very higher as compared to the conventional technique. So straight away we can see that the ultrasound technology is impacting the processing to get a better quality fruit and vegetable product. So we saw the large number of advantages which we are getting in the processing of fruits and vegetables. So let's talk about the limitations. So where are the limitations present in the uh, employment of ultrasound with the conventional drying process? So for an industrial application, ultrasound technology is better applied during the initial drying process. That means in the drying process, when the initial period when the product has been kept for drying, so the moisture content is very much high. So we need a higher drying rate in that period. So in that case, ultrasound can be employed to get a initial higher initial drying, because throughout the if we apply ultrasound throughout the drying process, so it is straight away loss of energy and waste if we talk about in terms of energy conservation. Secondly, the medium is an important thing to talk about when we talk about the ultrasound, whether it is simple distilled water, whether it is sucrose medium, or whether it is the airborne ultrasound where we're using air as a medium for the transmission of the power ultrasound. So selection of medium is also a challenge when we apply ultrasound for different type of fruits and vegetables, because different fruits and different vegetables have different texture. So in final product, we have to uh, see about the various advantages of the medium in order to get a better product. Then higher frequencies over 16 kHz can cause hearing loss in the operators, because in industrial scale the ultrasound equipment, ultrasound treatment would be on a larger scale. So if the proper measures are not being taken, then hearing loss could occur to the operators. This is an also a challenge. Then the ultrasound intensity required to achieve significant mass transfer enhancement and can lead to the formation of free radicals. We have to optimize the process. Here the optimization is needed, because if the ultrasound intensity is very high, then it could result in the formation of free radicals, which is a big no for the ready to eat products. So this is a point of consideration. Then secondly, the capital cost, the cost of establishing such an processing technique is involves a high cost of design. Then practical difficulties are also there for the industrial scale requirement. Then process conditions and complexity with equipment design. Although the above limitations combined, when ultrasound is combined with conventional drying, could still be commercially viable, particularly for the food industries that require shorter drying time. That means when we require the drying time of the fruits and vegetable as a shorter, so this could limitations could be taken into account, and a better optimization technique could be used to get the better quality product and higher product throughput. So the concluding remarks, it includes that ultrasound technology, which when conjugated with the drying technique, is highly effective in reducing the drying time, preserving the product quality, and lowering the energy consumption, because these three are the main aspects of the food processing technology. So ultrasound technology is highly effective in helping in all these 3 points. And if we see from a nutritional perspective, the ultrasound pre-treatment prior to drying additionally enhance the overall nutrient retention in the final product as compared to the conventional drying processes. So if we see the textural properties also, the textural properties, color retention has also been found superior to the final dried product when we are employing the ultrasound technology with a conventional drying process. So we are getting a product with higher nutrition, acceptable texture, and shorter process time. So it is taking care of also the processing time, then lowering the energy consumption, and also retention of the nutrient and acceptable product quality for the consumer. So it is also enhancing the product shelf life. So combined non-thermal and convective hot air drying process are cost-effective alternative systems to the drying systems with only single mode. If we talk about the single hot air drying process, therefore, an optimal drying system for preserving fruits and vegetables is a system which reduces the drying time and energy consumption, lowering the operating cost with minimum reduction in the final quality of the dried product. So thank you, all of you. Now you can ask if you have any questions.
Okay, thank you very much, Abhishek sir, for the giving us the very fruitful knowledge regarding the value addition of the our food product by drying, and also the special thank to our guest speaker who spent their valuable time to make this webinar beautiful. And I'm also thankful to you, the PU entire webinar team made this webinar successfully, and I extremely grateful to all the teaching and non-teaching staff and the member of the department, and also thankful to Mr. Ajay sir, our HOD of Agriculture Engineering Department, and who encouraged me and lot to conduct this webinar beautiful. And this is the last but not least, I am very much thankful to student to join from Facebook live, and without them, this webinar would not be possible. this conduct is not be possible. So thank you everyone, and thank you so much, Abhishek sir.
Thank you, Sandeep sir, and thank you to the Department of Agriculture Engineering of Parul University and the whole team for giving me this opportunity. And I'm really honored to present my thoughts on this topic. Thank you so much.